Hey everybody, and welcome back to Algebra 2 online. So I don't have too much to do today. Really, the plan will be to work through an assignment with some questions that kind of look like this, although this doesn't actually use the discriminant too much that we learned about last time. You can use it, but you don't really need to, I guess, is what I want to say. But the tough thing with the questions that are on the assignment for today are basically that they're kind of written with these weird, in this weird form here. You got like weird K's and things that just pop up. And sometimes that can be kind of hard to work with. So I just want to show you another example where you can see how that works with that. So this one says, I want to find the real value of K that's less than 0 such that this thing has roots at K plus 3 and K minus 3. If you know it has roots, like it has real roots, right, at K plus 3 and K minus 3, you could use the discriminant because you know it's going to be greater than or 0 to solve this. So you would know that b squared minus 4ac should be greater than 0. It's going to be one of those where you're going to have two distinct real roots, be doing something like that. But honestly, you don't really need it because it says you know the roots. If you know the roots, this last hint, think about what form of a quadratic might be helpful. So really, it would be much more helpful to use the factored form here. So if you know the roots are k plus 3, then like you're going to have x minus k plus 3 as one factor. And then if you have k minus 3 as another root, then you're going to have x minus k minus 3 as another factor. So we also know that basically this thing has to equal x squared minus 2kx plus 55, right? And we just know how when we multiply things out here, if we multiply out the constant terms, which would be like these two, right, it has to be 55. So we have to have that minus k plus 3, like all of that, times minus k minus 3 has to be 55. And that's just, because again, if you multiply this out, it gets you this. And so if you multiply out the constant terms, you have to get to 55. So now we have an equation that we can solve for k. So the negatives will go away right in the beginning. So really we just have k plus 3 times k minus 3 equaling 55. So then k squared minus 9 is 55. K squared would then be 64. So it looks like there's two possible values for k, right, plus and minus. But we wanted the less than 0 case. So we want k to equal negative 8. And that would be it. And for the assignment today, there's going to be a few questions that kind of use some tricks like this. Like you'll have to think kind of outside the box sometimes, using like the different forms of different quadratics. You will definitely run into quadratic inequalities too, which is why we study those before we study the discriminant, because you're going to get some stuff where it's like a quadratic and it's like greater than or less than 0. So you'll have to use some of these kind of tricks too.